Hi there once again and welcome to another Expresso mechanic tutorial. And in this one we're going to be building what you see on the screen, which is a mathematically accurate speedometer. In order to achieve this, we're just going to be using a combination of MoGraph and Expresso, and the MoGraph is going to be used to actually build the speedometer here. So it's perfectly simple really, and the Expresso is not too complicated for this, as you will see once we get there. But anyway, that's what we're going to be about in this tutorial. So without further ado, let's see if we can make this happen. We'll start by bringing in a rectangle. It's orientated in the correct plane, the XY, that's fine. The width will make 1 centimetre and the height 5. And we can drop this into an extrude. We'll do that. We might as well do it now. So we'll hold down the Option key, select extrude, and make the offset 0. And we can leave everything else as it is. Now we need to drop this into a cloner, so we'll bring a cloner in and just drop it in. And our cloner, we need to, for a start, the mode needs to be radial. That's the first thing we need to do. We need to give it a count value of 9 on this occasion. And its plane needs to be XY. And we can see, if we hit H, we can get a bit closer, we can see that we've got this clock-like setup. Now, it's not 100% correct because we've got to change the start and end angles. Our start angle, we want to be minus 130 degrees. And our end angle, 162 degrees, and that gives us a speedo-like setup. In our transform, I'm going to use the colour, and I'm just going to make these red. So that gives us our red subdivisions for the speedo, and that's our first cloner well and truly complete, so we can just close that one for now. We'll bring in a second rectangle, and the height we can make 4, the width 0.5 on this occasion, so slightly smaller than our previous ticks here. And then we can think about dropping this one into a cloner and an extrude. So we'll do the extrude first, just hold down Option, drop it into the extrude. Once again, just make this 0. And then we can bring our cloner in and drop this in here. Once again, the cloner needs to be a radial cloner in the mode. X, Y in the plane. On this occasion, we need a count value of 8. And once again, we need to work with our start and end angles. So our start angle will be minus 114. And our end angle, 146. And we can see that that set them up perfectly between our red ticks. Now, let's work with our radius here. Our radius needs to be 33.5. And we also need to work with our cloner's radius here. We didn't do that. So a radius of 50 is no good to us. We want the radius 33. And there we are. We've got it set up now. And we can see that these are they're all on this outer radius here. And these are just slightly less high than these. And that's the look I'm going for. Okay, so that's great. That's the first part of this done. So we can close this up and we can think about where we're going from here. We'll bring in another rectangle. And on this occasion, we'll make its width 0.2 and its height 3. So very, very small. The plane, of course, will be XY. We want that exactly the same. And then we can copy this 4 times, or rather 3 times, so that we've got 4 copies. So we'll command drag to copy. We've got our first 4. Bring in a null and drop this here. select all of these, command drag to copy, and then we're set nicely there. We can then just grab a hold of all of these and drop them into extrudes and make the extrudes 0 in the offset as we did before. We can then just close these up. And then we can select everything and we're ready to drop them into a cloner, but we'll do the cloner first. Just drop that in, place it here, select everything and drop it into the cloner. So we're set nicely there. Our cloner's mode once again needs to be radial, and then we can think about our count value. And on this occasion it needs to be 80, and we need to orientate it in the XY plane. So we can see that we've got the start, and we can see that we're going to place these in between. There's going to be 4 in between each of these. Then we leave the gap. That's what the nulls are in there for. Another 4, and then we need another gap, etc. You can see how that works. So our radius for our cloner needs to be 34, and we can see that that places them along this outer radius here, so that's correct. And then we need to work with our start and end angles once again. So our start angle we'll make -127, and our end angle we'll make 133. And there you go. We've got it all set up, and that's doing the job nicely for us. So that sets up the actual dial for our ticks anyway. We've still got a little bit more to do because we've got to put some digits in there and various other bits and pieces. But that's all of the ticks set up, and they look really nice. It looks like exactly like a car speedometer. Fantastic. So moving on from here, we can work with the digits that go around the inner edge. We'll bring in a text spline, align it middle. Its height needs to be 7, and I'm going to change my font. Now, I don't know what fonts you've got. I'm going to use Futura Bold on this occasion. So Futura, and it is set to bold. That's fine. That's what I want. You can use whatever text you think will be good, or whatever font you think your text needs to be in. So let's just put a 0 in there. Now, I've put a 0 there. Do not be tempted to put a return after it. Just leave it like this and then click here. So we've got a 0 there. The next thing to do is command drag this so that we've got a copy of it, and then put 160 in there, and once again click outside. So those 2 text splines are ready to go. The next thing to do is bring in yet another cloner, and we'll drop this one down here. And our text splines, we can just drop these both into extrude. So I'll hold down my option key, click, and then as per usual set the offset to 0. So they're all ready to go. We can drag both of these into our cloner and then set the cloner up. So our radius on this occasion, where are we? Well, for a start we'll change our mode first, so let's make that radial. And of course our plane needs to be XY as per usual. Now let's see where we are. Our count value we can make 9. And we also need to set our clones menu here. We don't want it in iterate, we want it in blend. Okay, so we need that for a start. We then need to change a few other things here. So a radius we need to make 22. Okay, so we're starting to go somewhere. We can see that we've got the actual digits ascending correctly, but our 0 isn't in the correct place because, of course, we've got to start working with our start and end angles. So let's see where we are. So our start angle of this occasion needs to be -138, and our end angle we need to set to 170. And now we can see that we've got something resembling the alignment of our digits with our red ticks, which is exactly what we want. But we need to check off this align here because we don't want them set up the way they are. And now we can see that we've got them. That's absolutely smack on. So that's great. It's looking nice. Let's see what else we've got to do. Let's have a look. Have we got to do anything else? No, I think we're okay. I think we've got that set the way we need it to be. The only other thing I might do, let's have a look in my transform window here. Yeah, I just want to change my position Y here. I'm just going to move that to -1. I think that just aligns them slightly better. That to me looks about how it should be. I think that's looking quite nice. Let's have a look here. Yeah, I mean, I think that does work. I mean, I've got to remember that there's 3 digits on this side. There's only 2 here. So I think that looks okay. I mean, if you wanted to, what you probably can do is put this to -1 as well, just to change the alignment slightly. Yeah, I mean, that to me looks pleasing on the eye, but it depends on the aesthetic that you're going for. But if this works for you, then set them both up the same way. But I'll leave that for now. I think that's okay. So that's our digits dealt with. I also brought in a digitized counter here, and I used an LED type text for that. So what I'll do is I'll just bring in another text spline. Just close this cloner up, just drop this down here. Again, I'll align this middle, change the font, and I'm going to use Quartz. Again, if you've got a font that looks similar to what I'm going to use here, then please use it. But I'm going to be using, where are we? Where's Quartz? PQ Quartz. There it is, Quartz. That's the thing I want. And I want my height on this occasion to be 10. And it's orientated correctly, so we can just drop it down here somewhere. And this will just give us a digital readout. We'll also drop this into an extrude. We'll make it 0 in the offset. And in our basic tab here, I'm just going to give this a color. I'll just make it red so that it looks like an LED display. Okay, so it's just got the word text in at the moment. It will have a 0 when we get the Expresso done, so I'm not too worried about that at the moment. And then finally, it's just the lettering for MPH. So once again, bring in another text spline, and we'll set this one up. And we need to use, have a look, where are we? We need to use 10 for the height. We'll set it middle for the alignment, and the text I'm going to use Futura Bold once again. Just come up here, find Futura Bold. There we go. There it is. Okay, and we can just simply put MPH there. And then drop this into our extrude once again and give it a value of 0 in the offset. And finally, we can drop it, or rather drop the text spline into the extrude. And there we go. And we'll just make that white. Go into our basic, into our materials, just make it white. That's fine. Yeah, looking really nice. So that's all set up. We could just get hold of that actually and just drop it slightly below the middle, somewhere there. I would say that looks about right for that. But again, you know, do whatever you feel. Whatever you think is aesthetically pleasing on the eye, please do it. Okay, great. So that's the actual elements of the dial all set up, and we've also got this digital readout set up as well. Fantastic. So that's really excellent, and we can just drop this down here. I think just leave it there because we know that this is a display, so we'll call this one digital display, just to differentiate between the two, and we know the rest of this is the dial. In fact, what we can do is select all of this, hold down the option key, press G, and just call this dial elements, if that's what we wish to say. Okay, so we've got our dial elements, and we've got our digital display. The next thing we need to create is the indicator, and that will be our next port of call. To make the indicator, what we'll do first is switch to our front view, so F4, and we've got our dial there and we can see exactly what we've got. Now I think that using these squares here, we want about 8 of them for the length of the indicator. So we want to go just a couple below here, or maybe even 7. You know, it just depends on whether what you think is right, really. You know, 7 could be enough. I think I will use 7 actually as a gauge. And then what I'll do is just move this over here, and I'm going to zoom in. See if I can fit 7 of those on the screen. What I really need is to see the actual divisions between them. We can do that ultimately actually, but what we'll do first, we just move that down there, see if I can get it on the screen, see if I can get those divisions in there. Well, I'm starting to, aren't I? So something like that. We'll switch on snapping and grid work plane, but we only want grid points. And then we can work with our spline pen tool. So we'll select that, and we can start with our first point. We'll make that down here. We'll come up to somewhere here. And then I'll go to this point here and then come down here, down to the bottom, and then close that off. Great, so I've got my indicator. The only thing is we need to select our model mode, and then we need to select our axis tool. At the moment we can see that we can't see the axes because they're in the center of the world. So we need to, in our tools here, come into axis center, hit execute to put them back in the middle. But I don't want them in the middle, I want them down here. So if we just change this, execute, we're somewhere near it, aren't we? In fact, the easiest thing to do is probably just bring them down to that grid point and just leave that as it is and just forget about that for now. But that's done that. That's actually moved our axes to where we want them. Let's have a look, see what we've got. In fact, it hasn't, has it? We haven't done that at all. What we need to do is select the axis tool first and then do it. That's better. Okay, great. So we've got the axes set up exactly where they need to be. Let's just go back to our 3D view. And we can see that that pointer is about right. That's going to work for us. But the next thing we need to do is orientate it in the correct place so that it's in the center of this particular dial. But we'll do that by placing it actually into a null and then setting our null up accordingly. Let's bring in the null. It's in the correct position, but it needs to be rotated in our rotation B here to -130 so that it's pointing at 0. Our spline, we can drop this into an extrude, and on this occasion we'll make the extrude 1, so 1 centimetre, so that our indicator has got some thickness. If needs be, you can make it slightly smaller, but I'll leave it at 1 for now. Now what we need to do then is drop this into the null and zero it out. So just zero that out, and we can see that it's pointing in the correct direction. We just need to zero these out and it should be where it needs to be, and it is. So it's pointing towards 0, exactly what it needs to do. In the basic tab, once again, I'll just go to automatic and make it red. Fantastic. So we've got our pointer, or our indicator, pointing directly to 0, and the speedo is now completely made. And we'll call this indicator and drop it down here. Fantastic. So our next port of call is to actually make the wheel that we're going to be using to drive the speedo, and that is where we're going next. And before we go there, I'm just going to change the display to garage shading lines and isopalms. Great, so let's think about making that wheel. We'll bring in a cylinder and start working with it. Now, our cap segments, as I'm in the caps, I might as well use the cap segments first. I'll set that to 3. In my object tab, the radius needs to be 26.5 and the height 20. Height segments, we just want 1. Rotation segments, we'll give that 5. And it needs to be orientated plus Z. Okay, fantastic. Let's just switch back to wireframe mode so that we can see what's going on here. Now, at the moment, it's not in the correct position. Let's just zoom out a little bit and move it somewhere here. So I'll hit O to work with our object. We can now make this editable by hitting C, and we can switch to polygon mode for the moment. Let's just see where we are. So we want to actually space things out and make things a little bit easier to work with. The center of it I'm going to leave where it is. What I think I'll do is switch to my edge mode and UL for loop selection, and I'm also going to come around the back here and just select this loop, and then we're going to move these out. So with our scale tool selected, I don't need to move them in the Z, so I'm going to lock that. Let's just move these outward if we can. Let's have a look. Oh, we're still in axis mode. We don't want that. Let's just move these out to just about there. I mean, you can do this totally by eye. It doesn't have to be perfect, but that looks good enough to me. We'll switch back to polygon mode and UL to select this inner loop here, and we also want the same here. And then what we can do is hit I for inset. We don't want preserved groups on this occasion, so we'll switch that off, and let's just apply and see where we are. Well, 5 is going to be too much. Let's offset by about 2. Maybe even less than that. I mean, we can go 1 if we really want to. That looks fine. We'll switch our display to lines. Hit MB for bridge, and we'll start cutting holes through this. So if we cut through those, those, and finally those, we can then switch back to garage shading lines, and we can see that we've got the starts of a 5-spoke wheel. Fantastic. Moving on from here then, if we UL once again and we select our inner loop here, again we can say I for inset. We could go minus 0.5. That's wrong actually. Let's just preserve groups for a start. If we do, well, in fact, let's go just 0.5. I shouldn't have gone minus 0.5. 0.5. And then we can D for extrude, and we can go this time minus 1. In fact, we'll go minus 2 just to make it a little bit deeper. Okay, great. So that is our basic structure for the wheel complete. We can then hold down the Option key and drop this into a subdivision surface. So select one of those, and now we can see that we are getting the basic idea for an alloy wheel. I'm not going to go too detailed with this. It's just to give you a basic structure for it, and that's looking nice. Now let's see what we need to do. As per usual in the options, I'm going to switch off isoline editing, and then we can work with our edges. So I'll switch to edge mode, and we can start thinking about what we're going to do here. So UL for loop selection, and select these 2 outer loops, and we'll just tighten these up a bit. And then we can think about working with these loops around here possibly, or we could even just leave those the way they are. What we might wish to work with is the loop around the edge of them. Let's just see where we are. Yeah, these here. That's what I really want to work with. So let's see if I can. I don't know whether we can actually get it to select that loops. One of those things with the loop selection where it doesn't always select what you want it to. But let's see where we are. Stop at non-quads, stop at poles. I don't think any of that's going to help. So what I might need to do is select those individually. So if I select that, 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 and that, and we just tighten those. Yeah, that's quite nice. That looks as if that will work quite nicely for us. Just tighten that up a little bit. We can do the same around the back, although for what it is, I might just leave it because we're not going to see it. So I'll leave that as it is. But you can see that you've got the basic idea for a wheel. I'm not too worried about going much further with that. The only thing you possibly can do is work with the subdivision here in the viewport. Just do that, say. Just make it 3 subdivisions in the viewport, just to really tidy it up and make it look really nice. I mean, that looks great for my money. I think that'll do perfectly well for the tutorial. But if you wish to go further, put a lot more detail in, as per usual, please do. But anyway, that's our wheel. The next thing we need is a tyre for the wheel. So we'll bring in a tube, drop that into our cylinder and zero it out. And then we can start working with the tube and see where we're going from here. What we will actually do is just drop that in the subdivision surface, but just at the same level as the cylinder so that it doesn't get affected by it. Okay, let's work with this tube. So again, our outer radius here, I'm going to make that 26.5. Let's just do that, 26.5. The inner radius, let's have a look, see where we are for that. In fact, the inner radius, we want to be 19. 19 for the inner radius. We'll orientate it, let's just get it orientated correctly, plus Z. Let's have a look at the height. The height needs to be 20. So that puts it on the outside of the wheel, that's fine. The height segments, we can just make 1 for that. I don't think we need lots of those. And where are we? Rotation segments, we'll make that 60 so that we get a nice smooth tyre. That looks really nice. And what we'll also do is fillet this, and I'll make it, let's try 1. Yeah, 1 for the fillet I think looks okay. I think we need to make a little bit of adjustment to the inner radius. We can do that quite easily. Let's see where we are. Let's just take that out a little bit further. Yeah, I mean, we can probably make it something like 20.5. No, perhaps a little bit less. 20.3. Let's have a look, see what that looks like. Yeah, I mean, I think that's fine. I mean, for the sake of the tutorial, that does look fine. I think it will work, won't it? Let's have a look, see where we are. Is it? Not quite sure that it looks absolutely centered to my way of thinking, but let's have a look, make sure everything's the same. Let's have a look at that. Yeah, right, okay, that isn't 100% centered, is it? Let's just drop it into here and center it correctly. Let's have a look. Where are we? That's curious. So that's there. That's there. Well, you can see that's slightly off. Okay, that's interesting. That's interesting. It looks okay though. I mean, it looks as if that's. Yeah, I mean, it does look okay, doesn't it? That was a bit confusing there for a minute, but it's. I think it is okay. I think it will work. I think it will work. Let's just switch to my front view object. Let's just check out what's going on. I just want to make sure that it absolutely is in the correct position, because it does look slightly off with the center, but that might be something to do with the fact that this is a pentagon shape. It just might be, yeah, it might be a trick. I think it is. I think it is orientated correctly. Yeah, I don't know. It's one of those weird sort of almost optical illusion type things that's going on there, but it does look closer here than it does up here. But that might just be, as I say, an optical illusion. But anyway, we'll leave it, I think, at that. Let's just do one thing here. Let's just rotate the wheel around its axis here. Yeah, I mean, it rotates okay. So I think we're okay with that. But it was, yeah, just a bit confusing at first there. Let's just set that back to 0. Right, great. So that actually completes the build for our wheel. And we've got all our elements created and we're ready to set up the Expresso. Let's bring in a null, name it Expresso, give it the Expresso tag. We've got the window open and we're ready to start thinking about doing some work. Now, just move this over here. Now, what exactly are we calculating here? Well, let's bring a formula in. And we can see that the first part of this formula involves taking the revs per minute times the wheel diameter, multiply that by pi, multiply that by 60 and divide the result by 160,934. And that number is the number of centimetres in a mile. So it's the magic number that we need to give us the miles per hour. And of course, the reason I'm using centimetres is simply because I have Cinema 4D set up with centimetres as its unit of measurement. Okay, so we know what we're about so far. So let's see how we go about calculating this particular formula. What I'll do is just do a bit of renaming here. I'll call this wheel. The cylinder I'll rename rim, and the tube tyre. And the first thing we need to do is bring in the tyre. And at the output stage, we need to come down to object properties and select outer radius, because that's what we're going to be interested in, because we need the circumferential length of our tyre. That's the first thing that we need to calculate. We'll bring in a math multiply. So come down to calculate math, set this up over here, change the function to multiply, and we can plumb our outer radius into the input number 1. And we'll multiply this by 2 to give us the diameter of our tyre. We can then bring in a second multiply and multiply the result of these first two here by pi, so by 3.142. And that gives us our circumferential length of the tyre. So we've got that far. Moving on from here, we'll bring in a third multiply, plumb the output of our previous multiply into the input number 1, and then we've got to decide what we're going to plumb into input 2. And we will remove we'll remove pi from there. We don't want anything in there at the moment. What we actually need to plumb into here is the calculation for revs per minute. So in order to get to there, we'll bring in a time node first. So drop that in there, remove the time port, add a frame port. So we've got that set up. And then we can think about what we're going to actually plumb this into. And it will be a range mapper. But what I'll do, I'm going to just switch back to my original file. And I've got a number of range mappers in here. But what we'll do is select the first one here and just take a look at what's going on in it. So we can see that we've got our input and output ranges set up. We'll worry about those a little bit later, but we've got a spline here that's going to start from 0, accelerate up to a plateau here, continue on, and then it's going to basically slow down and come back to 0. That's what's going to be happening in there. Now, the second range mapper here that I've got actually plumbed in at the moment, if we look at that, we can see that it's set up in a bit of a strange way. Well, what I did there, I set this up in such a way that it would perhaps simulate the gear changes in a car. So if we just run the sequence, we can see how this is going to cause the indicator to behave. So we get so far, now we're changing gear, it drops back a little bit because you lose a little bit of speed, and then it picks up again, and away we go until we change gear again, and then things repeat. So there we go, drop back a little bit, change gear, accelerate up a bit further. And it's not perfectly set up. I mean, I only did this to see if it was possible, you know, and I think it is. If you played around with it enough, you could get it to be really quite perfect, I think. But anyway, that was just something that I played around with. I won't be using this one in the tutorial. I'm going to stick with the top one here. So I'll Command C to copy this one, switch back to my tutorial file and open the Expresso here, and then paste this in. So we can plumb the frame into the input of the range mapper. Now let's see what we're doing next. Basically, we can take a look at the input and output ranges of the range mapper. So my input range is 0 to 1800, and the reason for that is because I need to extend the timeline to 1800, and that gives us a minute's worth of frames, because 1800 divided by 30, and I'm using 30 frames per second as my base, that gives us a minute. So 1800 divided by 30 gives you 60, so that gives us a minute's worth of time. So we can get our revs per minute. Fantastic. And then the output range, I've got 0 to 1611. Now, why have I arrived at 1611? Well, let's just open up our calculator here. And if we put 160,934 or 160,934 in there, and we divide it by 611, what do we get? Oh, sorry, 1611. Let's do that again. So where are we? 160,934 divided by 1611. That's what I want to divide by. Not quite that much. 1611. And we get 99.896, etc. So it's just about 100, and that would give us 100 miles an hour. So that's what we need to do there. Okay. I'm using 0 to 100 miles an hour because 100 is quite a nice round figure. I mean, I could have gone to 70. I mean, obviously you can't drive at 100 miles an hour on the road. Don't be naughty and do that. But, you know, I'm not encouraging people to speed. But I just used it because it's a nice round figure. Okay, so we've got that set up and ready. What we can then do is plumb this into the input of our multiply. Fantastic. So we've got it that far. We can then command drag to copy yet another multiply, because we need to multiply the result of this by 60 in order to give us the revs per hour. So we'll multiply by 60, and that gives us that. We'll leave the rest of the calculation just for a little moment, because we've got some other stuff that we need to do. We need to worry about what we're doing with making the wheel rotate. So in order to do that, we need a second range mapper. And once again, I'm going to switch back to my original file, open this up, and I've got a range mapper down at the bottom here, and this is controlling the wheel's rotation. So if we look in here, we can see that the spline is set up in a sort of rather interesting way. It starts from 0, accelerates up, levels off, and then slows down. And our input and output ranges, well, the input range is the same, the output range is slightly different. We'll take a look at that very shortly. So we'll Command C to copy this, switch back to the tutorial file, and do as we did before and paste this in. So we've got that set up there, and we can plumb the frames or the frame output from the timeline, the time node, into the range mapper. And let's just take a look at what we've got here. Now, what we've done here is multiply 1611 by 360 to get this figure. If we just get the calculator, let's just check that. So 1611 multiplied by 360. That gives us 57,900, or sorry, I beg your pardon, 579,960, which is what we've got in there. It's the number of degrees. So that the number of degrees this will rotate over the 1611 rotations. Okay, so that's how we arrive at that, and then we can simply drag in the wheel and give this to its rotation B. Okay, so we've got that far. So that's our wheel sorted out. We don't need to worry about that anymore. The next step, we can copy this math multiply and change the function to divide. And this is the calculation that we're going to use to finally get our miles per hour. So we're going to divide by 160,934. Okay, so we're dividing by the number of centimetres in a mile. and that's given us our miles per hour calculation. So coming out of here, we're going to get a value between 0 and 100 with the way that we've set this up. Okay. Fantastic. Moving on from here, we need another range mapper. So we can copy this one and we can plumb the output of our divide into the input of the range mapper. And we just need to set the thing up. For a start, we do not need to use the spline. We can uncheck this and that will prevent us from using that. So that's fine, we're okay. Our input range will be 0 to 100 because we know we're going to get a value between 0 and 100 out of here. And our output will need to be, it is set up as degrees, and that's fine because of course we got that from here. So it will be 0 and the upper range will be 162.5. So that will allow us to rotate the indicator between 0 and the 100 miles an hour over here. So let's bring in the indicator, and we'll use the extrude for this. We could use the indicator now, but I'll just bring the extrude in. Just plumb that into there and again transform, and it will be rotation B. Great, so that's got it just about complete, but there's one last step because we've got this digital indicator as well to deal with. Now, what comes out of the divide, it doesn't actually come out as whole numbers. It comes out as fractional numbers. Now, we want to round those down to the nearest whole number, and to do that, we're going to use a float function node, plumb the output of the divide into the value, and our float function will be floor because the floor rounds down values to the nearest whole value. So if it's 1.862, it'll be 1. Okay, so that's what we're using that for. Now, the last part of this then is to bring in the text spline from our digital display. At the input stage, object properties, text spline, and then plumb the output of the floor into the input there. And straight away, we're looking good. Okay, that's fine. Superb, and that is our Expresso expression taken care of. Now let's just see that we've got everything plumbed in correctly. I think we have. 4 multiplies followed by divide, that's absolutely correct. This plumbs into the 3rd multiply, and that's all looking good. So all things being fair, if I've done things correctly, this should now work. Let's just see if it does. Well, we can see that the indicator is moving and our digital display is working. Let's just see what happens. And look at that, it's going right the way up. And we're just about at 100. And there you go, we've got to 100 miles an hour. We just click off there so that we don't get the axes. And it'll go for so long and then it will start to decelerate. But yeah, it's all working exactly as it should. And you can see that the actual speedo does resemble the real thing because this is mathematically correct. So it does behave exactly like a true car speedo actually does. But yeah, there we go. And our wheel spins down and comes to a stop. Fabulous, and we're just repeating now because of the way we've got the timeline set up. But yeah, it's all working absolutely perfectly. So that is how you go about creating a speedometer for a car. Quite a simple formula really, isn't it? There's nothing fantastically complicated about it. A number of math nodes in sequence really, 4 multiplies followed by divide. And as long as you know what numbers go where and you know what needs to plumb into where, it really isn't that difficult to do it, is it? And of course the indicator here, that's an optional extra really. You don't have to put that in if you don't want to, but Yeah, a lot of modern cars do tend to have that display in there as well, so I thought I'd add it in just for fun. But yeah, there you go. That's how you go about doing it. And that just about brings the curtain down on this tutorial, because that's what I wanted to show you. So as always, I really hope you've enjoyed this video and that it's inspired you to try a few things within your own projects. And of course, if you wish to, you can make an RPM dial as well. But remember that you don't use the RPM from the wheels, you're using the RPM from the engine, so it's not going to be the same number. You know, you might need to do some calculations there to work out what the potential RPM of the engine would be at 100 miles an hour. And if you can do that, you can certainly create one of those for yourself. So there's a project for you. But anyway, as I say, I really do hope you've enjoyed this video. And if you have, please give it a like. And if you haven't already, then please subscribe to the channel, leave a comment, and of course, ring the bell. And wherever you happen to be on social media, please do share this video, because all this good stuff really does help keep the channel moving in the right direction. But anyway, that just about brings this one to a close. So I'll see you very soon on the next tutorial.